Today we're going to talk about a specific type of function. So in Algebra 2, this is lesson 2.1, and we're going to talk about a function called a direct variation. So first we need to be able to identify a direct variation. A direct variation is a variation that in equation form looks like y equals k times x, and k is called the constant of variation. And the constant of variation simply means, is there a specific relationship between x and y in each of our ordered pairs? Another way to write the equation is y divided by x over equals k, and k is the constant. So we're going to start by identifying a constant of variation. So for each of these tables, we're going to look for a pattern by dividing the y coordinate by the x coordinate. So for that first point 1, 2, we're going to take the y, which is 2, and divide it by 1. And what we're looking for is the same constant. So for the second point 3, 6, I'm going to take 6 divided by 3, which is 2, and 8 divided by 4, which is also 2. And since all of these have the same ratio or constant of variation, we have a direct variation. So yes, this is a direct variation. And then what we're going to do is we're going to plug that value in for k. So the equation is y equals 2x, since our constant of variation was 2. Let's take a look at the second table. We're going to divide y by x, so 4 over 1 is 4. 8 divided by 2 is 4. And 11 divided by 3 is 3 2/3. And as we look at these values, notice that they're not all the same. So this second table is not a direct variation, and we just simply can't write an equation to demonstrate it. Here's a horizontal table. We're still going to do the same thing. We're looking to determine if this is a direct variation. So we're always doing y divided by x. So here is our first point, and y is negative 21. Divided by x is negative 7. The second point, negative 14, divided by 2 is negative 7. And negative 7 divided by 1 is negative 7. So yes, this is a direct variation. And we're going to plug into our direct variation formula. And the constant of variation is this negative 7. So I'm going to put negative 7 in for my k, and I have a direct variation. So now we're going to write some direct variations given the fact that we have a direct variation. So it says, suppose y varies directly with x, and y equals 9 and x equals negative 15. What is the value of y when x equals 21? So what's happening here is we have a relationship between x and y for every value of x and y, and we're looking for the ratio to start with, and that's k. So we're going to take the y over x for the first information that was given. It says y varies directly with x when y equals 9 and x equals negative 15. So we're going to plug in 9 for y and negative 15 for x. And that's going to help us find our constant k. We can reduce 9 over negative 15 to 3 over negative 5. So our constant of variation k is negative 3/5. So the second step after we find our constant is to write our equation y equals kx. So y equals 3 over negative 5x, and this is our direct variation. Okay, and then to answer the second part of our question, it says what is the value of y when x equals 21? We're going to plug 21 in for x. So we have y equals 3 over negative 5 multiplied by 21. So y, when x is 21, y is going to be 3 times 21 is 63 divided by negative 5. 5 goes into 63 12 times, so we get negative 12 and 3/5. And that is the answer to the problem. So I'm going to have you do this one, so go ahead and pause the video and solve this problem. Suppose y varies directly with x and y equals 15 when x equals 3. So first we're going to find our constant of variation. So y is 15, x is 3, and we get 5 for our k value. So k equals 5. Our direct variation is y equals kx. So I'm going to plug in 5 for my k. So here's my direct variation. And now I'm going to solve that for when x equals 12. So y equals 5 times x, x is 12, so y equals 60. So when x equals 12, y equals 60. So let's take this information and apply it to the real life. So a salesperson's commission varies directly with its sales, which means that we have a direct variation. In this context, commission is a percentage of what somebody sells they get in their as their money for their payment. And usually it's a percentage. So for example, if I were to sell $100 worth of something and I get 12% commission, it means I would make $12 out of that $100. In this instance, for $100 in sales, the commission is $85. So we're going to define y to be our sales. That's the first thing you're going to do, and x is going to be our commission. So the first thing we're going to figure out is what is the ratio between sales and commission. So we're going to do y over x to determine our k value. And in this case, y is 1,000. We have $1,000 in sales. And x is our commission, which was $85. So if we go ahead and divide that, 1,000 divided by 85, we get approximately 11.76. So that's our k value. K is 11.76. All right, then what we're going to do is write that in our direct variation. Y equals kx. So I'm going to plug 11.76 in for k. Here's my direct variation. And then we can use our direct variation to answer the question. What is the commission for $2,300 in sales? All right. So our sales was y in this case. Our sales was y in this case. So we're going to plug that 2,300 in for y. So 2,300 equals 11.76x. To solve this equation, we're going to divide by 11.76. And x, or our commission, is about $195.58. And that makes sense. If you're selling $2,300, you're going to make part of that in your commission. The last thing I want to talk about is what a graph of a direct variation looks like. So I've listed two direct variations, y equals 3x, and what we're going to do is we're going to make some t-charts to go with both of them. So I'm going to do -2, -1, 0, 1, and 2 as my values. I want you to pick at least 3. And then we're going to plug them into our direct variation for x. So I'm going to start with plugging in -2. So 3 times -2 is -6. Now I'm going to plug in -1. 3 times -1 is -3. Then 0, 3 times 0 is 0. Then 1, 3 times 1 is 3. Then 2, 2 times 3 is 6. And once I have my ordered pairs, I'm going to plot those in a coordinate plane. So starting with my first point, -2, -6, so left 2, down 6, -1, -3, 0, 0, 1, 3, and then 2, 6. And then do very carefully try to draw your line. And this is the graph of the direct variation y equals 3x. Okay. I'm going to just pick -2, 0, and 2 for the second one. So plugging -2 in, -1/2 times -2 is 1. -1/2 times 0 is 0. and negative 1/2 times 2 is negative 1. And I'm going to plot those in a new graph. And if I plot those points, negative 2, 1, 0, 0, 2, negative 1. And that is my graph of y equals negative 1/2 x. It's a direct variation. So one thing I want you to notice is that direct variations always go through the origin. Every single time this goes through the origin. And if it does, it's a direct variation. If it doesn't, it's not a direct variation. So keep that in the back of your mind as you're graphing these. All right, enjoy.